Today we are going to talk about Lesson 9.2 in our Chapter 9 packet, Linear Regression. Today we're going to talk about regression lines. So after verifying that the correlation coefficient between two variables is significant, we next determine the equation of the line that best models the data, the regression line. So you can see here in this example we have our scatter plot, those dots. And then this line that's shown through them, that would be the regression line. It's the linear model that kind of best fits that pattern of that data. It can be used to predict the y values for any given x value. So once you've created that line, you can guess what would happen for the next x value. So like in lesson 9.1, we had our GDP and CO2 levels. So if you had a regression line for it, you could give a GDP and you could predict what those CO2 emissions would be. We also talk about the residual. The residual is the difference between the observed y value and the predicted y value for a given x value on a line. The formula is residual equals actual minus predicted. So R equals A minus P. And what's happening is our predicted is our regression line here. And then our actual is your scatter plot points. So the residual is just finding that distance there between the regression line and the scatter plot points. Then the least square regression line, the line of best fit, that's the equation of the regression line for which the sum of the squares of the residual is a minimum. So it is the line that best fits the data. That's why it's called the line of best fit. It's where that difference between the predicted and the actual is going to be the smallest. So our formula is y hat, okay, we call that y hat, equals ax plus b. Y hat is our predicted value. A is our slope. And b is our y-intercept. You'll notice this looks a lot like y equals mx plus b, the basic linear formula. Let's talk a little bit about our slope and y-intercept. Slope A, when you move 1 unit to the right on the x-axis, you move a units on your y-axis. You would move up the y-axis if a is positive, and you would move down the y-axis if a was negative. And then your y-intercept b is the value b when x is 0. Okay, it's the same thing you would have learned in Algebra 1. Your y-intercept is where x equals 0. It's kind of that starting point on the graph. So let's look at our example. We're going to write the equation of the regression line for our gross domestic product and carbon dioxide emissions data, and we're going to answer some questions about it. So there are a couple of steps that we want to follow. We want to make sure that our stat diagnostics is on. You go to stat edit, you put in your x values into L1, your y values into L2. You hit stat calc 4. Make sure that your x list has L1, your y list has L2, and then in the store regression equation, you're going to hit alpha trace 1, and that is going to put your regression equation onto the graph. Okay. So you hit calculate, it's going to give you your slope and your y-intercept. So take a minute here, pause the video, and put this information into your calculator. and come back for those answers for the A value and the B value. Okay, hopefully you got a chance to try your calculator out. Check your A and B value. Now I want you to pause the video and try and take that A and B value and write it into our least square regression line. So check that formula. Okay, hopefully you got a chance to do that. You take your A, you plug it in front of that X. You take your B, you plug it in at the end. It was positive, so I put plus 102.289. And there we have our regression equation. Now I want you to try 3 and 4. We are going to interpret the y-intercept and the slope. So look at that definition of y-intercept and slope and see what you can think about. And then come back for the answers for 3 and 4. Okay, so let's look at 3 and 4. What is the y-intercept for the situation and what does it mean in context? So our y-intercept was our B, our 102.289. And if we think back to that definition of our y-intercept, it's the value when x is 0. So CO2 emissions, our y value, is at 102.289 when the GDP is 0, because GDP is our x. So we have taken that definition from the previous page and we've just put some context into it. The same thing with what is our slope for this situation and what does it mean in context. We've got our slope, our A value. So the slope is when you move 1 to the right. So as the GDP goes up by 1 trillion, because the GDP is counting in trillions, then the CO2 emissions go up by 196.152. I said go up because our slope is positive, so it is going to be going up the y-axis. Next, we have predicting y values using regression equations. So we have the regression equation from our gross domestic product in trillions and our carbon dioxide emissions. So that's our regression equation that we used on the previous page. We're going to use this equation to predict the expected carbon dioxide emissions for the following gross domestic products. So we are given a gross domestic product, which is our x values. So in order to find that predicted y value, all we have to do is take our equation and plug in our x value. So for this first one, 1.2 trillion. So it's already being counted in trillions, so we just put that 1.2. And then we put that into our calculators. And our predicted carbon emissions, CO2 emissions for $1.2 trillion GDP would be 337.671. Okay, I want you to try that same thing on B and C. Pause the video and come back for the answers. Hopefully you got a chance to try that. Here are our answers on B and C. Go ahead and pause and check yourself, and then we are going to do that part right below it. If the actual carbon dioxide emissions for a country with a gross domestic product of $2.5 trillion is 600 million metric tons, what is the residual? So residual is our actual minus our predicted. So residual for that 2.5 trillion, our actual is that 600 million metric tons, and our predicted, we have that just above from C, 592.669. So if we do that math, our residual would be 7.331. There we go. So next we have a check for understanding. It's over our Barbie Bungee activity. So go ahead, take a minute. They're all problems that, like we did in our notes. So try 1 through 6 on page 10. Pause the video and come back for the answers. Okay, here are the answers to our Barbie bungee activity. There's our least square regression line in number 1. And then we need to find out what happened for 5 rubber bands, so we plug in that 5 and we get our answer. 3 finds our residual. Do your actual minus your predicted. And then 4 wants us to predict for 20 rubber bands, so we plug in our 20. And then it asks, would you trust this prediction more or less than the prediction you made in number 2? So this one's not really in our notes, but we would actually trust it less because it is far from our data. Our data stops at 7, so making that jump up to 20 is something we call extrapolation. And you always want to avoid extrapolation. And then here are the context for our y-intercept and our slope on 5 and 6. Pause if you need to.